Welcome to part 2 of the Steel Detailing Project Startup video training series. In the first video, we were actually walking through a real-life project and some of the example things and RFIs that you would find as far as relationship to the design or the specifications on the project. In this video, we're going to take a look at the fabricator standards as well as the erector standards, as well as look a little bit at the schedule and the milestones, and we're going to take a look at it from that side of the information that you need on the project. All right, so what are some of the items that we want to ask the fabricator? Hands down, the first thing that I ask is, how am I going to communicate with the fabricator? How am I going to submit questions and clarifications, and how does he want me to exchange information with him? So really here, one of the top questions is, some fabricators are like, please don't drown me in RFIs. Don't ask lots of RFIs. Let's put all the questions on the detail and erection drawings with approve or verify everywhere. And then there are other fabricators that say, hey, no, I want everything itemized in individual RFIs. Send me those and then just clarify and put those RFI numbers on the out for approval drawings if they haven't been answered by approval. So I always ask up front at the project kickoff, how do you want me to communicate? And you want to ask this right away because this impacts a lot of the overhead and management that you have to do as a detailer on your project. Then I ask for what's the RFI template that I'm supposed to write my RFIs or submit them in. Do I write them on my paper with my logo, or do I use the fabricators? Do I use their RFI numbers or do I use mine? Some fabricators will just pass your RFIs directly on after they've reviewed them, and some will actually transfer that to their own RFI system as well as their numbers. And some RFIs go to the EOR and some go to the contractor, and then some don't. Some are just for the fabricator. So you want to get that clarified. Now, typically when writing RFIs, I like to keep it one subject and one specific issue per RFI. I try not to ask 5 or 6 questions. I may have some sub-clauses in there that just kind of articulate a few points about the main question itself, but I typically don't ask more than one question per RFI, and I keep it pretty concise and clear. Now, you got to be careful on like writing it too short or too generic or too simple. Because sometimes there's an art form to writing RFIs that if you write something too generically, or if you don't sort of lead the answer that you're looking for, I usually write RFIs that are more clarifications, unless it's just I straight out don't know what to do. But I'm more kind of guiding and providing all the detail that I need in order to get exactly the answer I want. I've seen some detailers write like one-liner RFIs, and then they get a response back, and it's not, the engineer didn't know exactly what you were asking, and so they gave a fairly generic response back, and then you have to follow up with another RFI, which causes delays. Then you want to get verified whether all RFIs and communication go through the fabricator, or if you can actually directly communicate to the contractor or the engineer of record. Usually it's almost always through the fabricator because they want to review things first, and our contract is with the fabricator. Sometimes a connection engineer has a direct line to the engineer of record, especially if we're working closely together to kind of work on some complicated connections and get things verified. So that's usually the only case where I see that where we have a direct line outside of just working through the fabricator. Then basically, if you have any phone calls, so sometimes it's faster to just pick up the phone and say, hey, can I get this clarified real quick, and can we just take a look at the design and get something answered, versus having to write extensive RFIs. And so usually what I'll do is if we have a weekly call with the fabricator and we're just getting clarifications, then you just want to follow up with a written summary that will be a record of conversation, and you'll just keep a log and assign a number to that. Just like you assign numbers to the RFIs, you should assign a number to an ROC, or a record of conversation. And keep track of all the emails on the project, especially if decisions are made via quick emails or directions are made via emails. Keep all track of that. And then at the project kickoff. Now, this is a really important thing here in communicating with the fabricator. I see some detailers will just get started too early on the kickoff, so they'll kind of go into the kickoff like looking at that as their opportunity to sort of get educated on the job, and that's a definite no. Basically, when you walk into a project kickoff with your customer or fabricator, you should be almost more educated than they are, or prepare yourself in a way where you're going to be the expert on the phone about the project, and you have a lot of the questions and even some of the RFIs that you're looking for the early milestones on the project ready to go and even to discuss during that kickoff. What you're hoping to do with the fabricator is go like almost even page by page in the design, or go item through item in the scope and make sure that you have everything clarified. And so you want to get some of these big questions that you're going to actually see in the slides in this presentation or this part of the video, and you're going to see if you can get some of these clarified during that kickoff. Best thing I can say is, buy yourself some time, get a couple days, get familiar with the job, start looking at the RFIs, start to understand exactly how you're going to do the job and what you need to get from the fabricator, and be prepared when you go to the kickoff. So when you get there, you can get as much of the information during that kickoff versus writing lots of RFIs after the kickoff. Now, the next thing I'd like to get a lot of clarification on is the anchors, bolts, and welds. Now, although a lot of this information is shown on the design drawings, there are certain nuances and things that I want to get clarified with the fabricator and the erector. And so let's go through some of that. Very first thing is on anchor bolts. Are you using leveling nuts or shims underneath the base plates and with the grout? Do you need a grout hole in the base plate to get access for the grout? Looking at the oversized holes, are plate washers going to be required on the base plates? So these are things, and then even the grout thickness if you're using leveling nuts. If the engineer shows a specific grout thickness and that may be not enough to actually get adjustment room in there, you start to ask questions of that. So these are all things that you're doing in combination with what the design shows, as well as getting clarifications with the fabricator and the erector. Bolts is another really big thing. Oftentimes you'll hear fabricators and erectors say that we want to use TC bolts or tension control bolts everywhere. So TC bolts are great. They will fully torque the bolt, but the advantage of them for the fabricator and erector is that they can much more quickly erect the job. They can get the bolts in, tighten them up, and they can move on. And so if they can at all possible, many of them will use TC bolts. Now, the issue with that is you need to specify that on the job and in your bill of material and your bolt lists. But also you need to actually take a look at like skewed connections or certain connection types and make sure that there's access for the TC or the torque gun to actually get access to tighten those bolts. Now, another thing to watch out for is the N versus SC versus X designation on the bolts. Now, most of the time you'll see A325 grade and then N, which means threads included in the shear plane designated on the design drawings or the connection details and designs. Now, there are some cases where X is specified. If you ever see a job where the structural notes or the design details call out a bolt grade and then an X designator at the end of it, this means excluded from the shear, threads excluded from the shear plane. This is something you need to go back and talk with the fabricator right away because it's harder to detail, it's much more time consuming, and then it's also harder to verify that that's actually been done out in the field. And so really, if you ever see a job, it's very rare. Most engineers know like that it's not convenient and really productive or efficient to design to that. But if you ever see it, just talk with the fabricator right away. Now, the other common one that you will see is sometimes the bolts are designed to be for slip critical connections. So you'll see, like for instance, A325 SC or slip critical. If you do see a joint or a detail that has SC bolts on them and there is paint on the job, you'll oftentimes need to mark on the shop drawing no paint within like 3 inches of the holes or the connection surfaces. And so you'll just need to keep an eye out for that and ask the fabricator exactly what you need to do there. Then expansion bolts, wedge anchors, and epoxy bolts. Now this gets a little bit tricky sometimes just because of the fact that there are different manufacturers. Sometimes the engineer record will actually specify a manufacturer and a very specific product number on the job. So you want to get that clarified with the fabricator and just make sure that that's what they want you to follow suit on, or if there's an alternate that they've RFI'd or that they're going to go ahead and procure, that you designate that however they need to on your shop drawings. Then on welds, This is also a big deal. Basically, at the project kickoff, you want to clearly understand if there's any groove welds, partial penetration or complete penetration, especially the complete penetration. What is the pre-qualified weld that they want to use, and what is the bevel angle, the root opening, the backing bar detail and information. Do you have to detail the backing bars, or do they just include those? Are the backing bars needing to be removed from field welds and moment connections? What are the rat hole details and types that they would like to use? These are all things that you want to get clarified in the project kickoff or a fabricator specific RFI, especially because this work oftentimes costs a lot of time as far as doing in the model if it's manually done versus automated through the connections. As well as extra time to call out those details and that information on the shop drawings. Now, shear connections make up about 80 to 90% of the connections on the job. And so when you look at this, you're going to want to talk with the fabricator about what are their preferences, especially if the fabricator is delegated to do the connection design. Now, when we look at this, we're going to basically see whether or not it's clearly specified in the general structural notes or in the scope list, whether the fabricator is doing the connection design or the engineer of record. And when we kind of look at it, if the fabricator is delegated to do the connection design and they hire a connection engineer like RexCon, then basically what we want to figure out is what is their preference. So this one fabricator on this job, they wanted shear tab connections first for their beam to beam, and then clip angle for greater reactions. So you can get a greater shear capacity with the number of bolts on clip angle connections than you can on a shear tab. But shear tabs oftentimes are easier and more friendly to erect. So then looking at beam to column, if you have W flange columns, again, you may want to start with shear tab connections, and beam to column webs, you want the shear plate to actually extend past the toes of the flange, so that way you don't have to erect anything on the inside of the web of the column. So again, that's an erector preference, makes it easier to erect if everything is outside, away from the flanges, and you're not actually having to lower the beams into the column web and between the toes of the flange. Now, when you look at back-to-back clip angle connections, so if you do have to do a clip angle job, or you do have certain connections that are clip angle, and there's a beam on either side of the column web or either side of the supporting beam web. So when you look at the detail image here on the right-hand side of the slide, you'll see that there's actually, I've staggered or dropped some of the clip angles in order to get what is called a safety connection. So based on OSHA standards, if you have two beams that are the same depth and have the same number of rows of bolts, what you have to try to do is you have to try to offset the clips or add an extra row of bolts on one of them, so that way one beam on one side can be fully erected without having to share the bolts with the other side. So if you ever see any back-to-back connections where you have to do clip angles, you're going to want to look at the detailing standard and ask the fabricator, how do they like to handle safety connections? Then also looking at clip angle connections, the two most common conditions you'll see is the fabricator prefers to do bolted welded or bolted bolted. If you do bolted connections, which means that there's bolts in the clip angles going to the supporting member as well as a shot bolted to the supported member. If you do that, you either use wider gauge angles, so that way there's clearance to actually put the bolts in and to tighten the bolts, or you'll stagger the bolts up and down. So there are conditions like that. So bolts in the supported member are at a different spacing than the bolts in the supporting member. And then for bolted welded, which is the most common that I see, you'll usually see a shop weld of the clip angle, which is actually what's shown in this picture here. The clip angles are shop welded to the supported member, and then they're bolted in the field to the supporting member, which is going to be like a girder or a column. Now, the other thing you want to ask the fabricator and erector about is short slots. And sometimes you may get an answer that's different between beam to beam connections versus beam to column, especially when you're talking about shear tab connections. I've heard some erectors say that, hey, beam to beam connections, no problem, give me short slots so that way I have extra room, and especially at skewed connections or bent plate connections, they'll want the same thing. But at beam to column, I've heard differences of opinion on certain erectors versus others. Some erectors actually don't want short slots at beam to column because it actually affects their ability to plumb the building and the main grid line steel and beams to columns. So for beam to beam, they may say yes to short slots, but beam to columns, they won't. So you want to get this verified at the early stages of the project. And then lastly, if there's standard fabricator connections, especially if the fabricator is doing the delegated connection design, they may have standard clip angles or standard shear tabs that they want to use. And so what that means is they've already prefabricated a lot of certain clip angles or shear tabs that work with their standard connection design tables that are worth a certain capacity and work on most of the jobs that they do. And so they'll have these standard parts prefabricated and kind of sitting like in a pile or a bin that they can use from job to job. If you do have a project where you have standard parts, including standard part marks, you can set those up both in STS2 and Tekla. So that way, anytime you do the modeling of those pieces, it'll actually use those piece marks. And then if there's something that's unique on the job or job specific, it'll take a regular standard submaterial part mark. So on shear tab jobs, one of the first things you want to ask the erector is which side of the beam that they want the shear tabs to actually be on. There are two general philosophies that I've seen. There's the shaking hands or the opposite side. So on one side of the left end of the beam, for instance, they want it on the far side, and then on the right end, they want it on the near side. And when you look at the actual image here in the model, I'm showing you an example of how they actually erect that. So when you see it diagonal or skewed there, what happens is the beam is often longer than than what you can actually just lowering that down. So if the crane is lowering the beam, they actually have to sort of skew it a little bit so that way the length of the beam can get between the beams that it's framing to. And then if they have the opposite hand, then basically what they do is they bring the beam close to where they're going to actually erect it. They twist it a little bit, and then you see based on the arrows there, they sort of just twist it back into place. So one side is going to be on the near side shear plate and the other on the far side. So this is a really good, some certain erectors prefer this if there's like tight spacing on the beams, like as far as the bay spacing, and the beams are really long. So this is just like very isolated to that specific spot. They twist the beam, put it in, and then they move on. Now the other side is where you basically put the shear tabs on the same side. Now, again, they do the same process here where they twist the beam a little bit, but they just do it offset to the side of the beam. Now, I've heard erectors like this because then they consistently tell their crews that, hey, the shear tabs are going to always be on the south side or the north side or the east side and the west side, except in special conditions or cases. And so the advantage here is that it just keeps it consistent. It's also easier for detailing and fabrication if all the tabs are consistently dimensioned to the same face and the same framing side. So there are advantages to both, but it's always worth asking the erector and the fabricator. Now, there might be cases on a job where they want shaking hands for all the interior beams, so beams that are inside, framing the girders inside the bays of the floor. But at exterior, where there might be shop-applied mud stop or pour stop or slab edge, they may want the beams to frame from the outside inward, or some want it to frame inward out. So sometimes you may have interior beams shaking hands, but around the perimeter, they want it to be done a different way. So this is always worth asking the fabricator as soon as possible during the project kickoff. Now, most of the jobs that we do, we see vertical bracing, and oftentimes it's HSS tubes that are slotted around or knifed around gusset plates. Now, some of the questions that I like to ask right away are erection bolts required? And some fabricators and erectors say, hey, I only need one erection bolt there on each end, and then others want two. Now, the cases where I've heard that an erector wants two bolts is because they'll actually use one hole to place the bolt in, and then they'll use the other hole to actually pin, so that way they can hold it in place or sort of position the brace and hold it in place, especially if there's tolerances and things that aren't exactly lining up. So that's always something that you want to ask right away. And you'll also want to ask what grade of bolt is used. Now, oftentimes for these braces, especially if only one bolt's being used, I'll still provide a structural bolt there, like an A325 bolt. But sometimes A307 bolts will meet the capacity and work, especially because these longer bolts start to get a little bit more expensive. So always worth asking the fabricator and erector. Then the next thing I ask is the slot details. And I've heard variances on this from the fabricator. When you're putting in the connection, you definitely want to do radiuses basically at the slot. So we're looking here at the section AA. And you want to figure out how much do you want to actually elongate or lengthen that slot past the actual length of the gusset plate, or where the gusset fits into that slot. Then you want to give like a 16th to an extra, eighth or even 3/16 on the width of the slot. So that way, if there's any warping on the gusset or even warping on the tube, I've seen some fabricators actually report back to me that they actually do the cut in a certain way on the tube, so that way there's no shrinkage on the actual width of the slot, so that way they can kind of keep that nicely placed. So adding a little bit of tolerance in there for the field to actually wrap that around the gusset is something you want to ask the fabricator. Then what I usually do is, if the engineer of record or the connection engineer specifies a weld length, I'll actually usually add a 1/2 inch to an extra inch of the lap dimension. So you can see here I've highlighted, I put 6 inches, and I detailed the lap and the gusset to be a little bit larger, just so that way I'm assured that I'm getting the minimum effective weld length that the engineer specified, especially if there's any tolerances or anything going on out in the field. I've given extra cushion or extra length there to make sure that I'm covered. Then if you have certain conditions where a brace is going to a beam and a column, I always ask, well, what am I shop attaching to? Am I shop attaching the gusset to the column or the beam? Am I doing bolted and welded, or am I doing welded with field welds? So those are also good questions to get clarified. Some erectors live and die by it being one way or the other, so it's really important to ask this. And then basically the other thing here is, if the engineer doesn't specify a max, then usually the typical clearance is putting the end of the brace 1 inch away from as a framing clearance point. So that 1 inch is a good dimension or a good standard there, because there's going to be the fillet weld or the weld between the gusset to the beam or the column, and you want to make sure that you're clear of that, as well as just give any kind of erection tolerances for the field. Now, the other thing I'll do is, not all detailers do this, but I've heard a lot of these conditions here, depending on the angle of the braces and how tight the gusset is, I'll hear a lot of erectors actually complain that they cannot erect the braces. They can erect one, but they might not be able to erect the other. So what I'll do is, I'll actually in the model start rotating the pieces based on the slot lengths that I have there, and I'll maneuver around and see if the actual brace is erectable, or I'll coordinate with the erector and say, hey, what are the minimum clearances and dimensions you need in order to assuredly get both of those braces in there without any conflict or any problems. All right, so what are some additional items that I also ask the fabricator? One thing is that if you see a lot of full depth stiffeners on the project, I ask if, based on beam tolerances, or if they have fitting equipment and machines that actually need clearances, I ask if they want a 0 gap or if they want a 16th or even larger gap. In many cases, I'll hear 16th top and bottom. Then I ask about verifying the paint and clean spec. So we talked about that in part 1. But I ask the fabricator to just verify this with me, because it's such a big, costly item if it's done wrong. And so I make sure that I even send them sample drawings of how it's called out, especially if there's no paint areas. I ask them for standards on galvanizing, if there's weep holes required, the way they want seal welds done, if there's a maximum length of assembly that can be put in the galvanizing tank. All of these things are things that you want to do extra due diligence to make sure you're covered on. Then I ask about safety cable and fall protection. Oftentimes you'll see this in the detailing standards, but you might see these requirements change from job to job. Some fabricators like to drill holes in the columns and the beams for fall protection, and then some actually like to weld tabs or add eye bolts and things to the actual the piece. It just depends on how they're set up and how they would like to do that, so always get clarification on that. And oftentimes you're going to be putting safety cable holes at the perimeter columns or at columns that are near floor openings that'll be there even after the decking are down, and that the contractor needs to make sure that there's fall protection and safety protection even after the steel has been erected. Then you're going to want to ask the fabricator and erector about built-up assemblies. If you have trusses on the job, bents, or modules, or even stairs, anything that is more than just like a standard beam and column or brace, you're going to want to get direction on, are there splices required? What's shop welded versus field welded? What's the maximum weight or length of an assembly where a splice might need to be required? And you'll want to get clarification on that. Now, another common thing is doing lifting lugs. On columns, if you have really tall and heavy columns, They may want a lifting lug either on a splice plate or drilling a hole actually in the top of the column. So you want to get clarification on that. And then certain beams or trusses, there may be, based on the erection engineer, certain lifting requirements that are needed, and the fabricator may ask you to apply those details during the detailing. And we need to just verify that's in our scope, and that's part of our price. And then again, looking at splices, shop splices versus field splices. If you have columns that are more than 2 or 3 stories high, the length of the assembly starts to come into consideration of what you can load on the truck, as well as decking out in the field. A certain number of floors need to be decked before you can erect the next level of steel. And so these are all things that you want to quickly verify on the job at early stages of where are splices, what will the splice detail be, and what are the welding requirements or bolting requirements. Now, another big one, this actually can be a huge coordination issue on a job, is the pour stop or the slab edge around the perimeter of the building. Depending on the exterior type of the building, whether it's a window wall system or a precast exterior, and depending on the loads that are being transferred from the exterior or the cladding to the actual structure, is going to affect a lot of the details. Now, you'll also want to check the scope of like what's included in the fabricator's scope versus the deck manufacturer's scope. If the engineer shows light gauge material as the pour stop or the slab edge, and nothing is really kind of transferring any load through there, the engineer just might be specifying by deck manufacturer if it's gauge. The structural fabricator won't provide that. Now, if you actually see a bent plate or an angle called out that's a structural size, 3/16 or larger, then you want to start asking the fabricator, hey, is this going to be shop applied or is it going to be field applied? Is there a maximum length to the pieces that you want? Some fabricators don't like 20-foot long pieces of bent plate detailed because, one, they may not be able to bend that length, or they may not be able to procure it at that length. And then also it's harder to handle. And then also from a welding point of view of welding that and doing the stagger weld along the length of that, they like those shorter pieces that they can control and prevent like deformity on. Now, some fabricators don't like to weld that bent plate. They actually like to bolt it. So you have to ask that, and if it is bolted, what's the edge distances and the slot requirement that's needed for tolerance to do those. If it's field applied, are you just going to send out lineal footage of material that they will field cut up and put up there? And then is there any closures at the corners, like corners of the building where one plate, bent plate needs to terminate and wrap around the column and pick up for the other corner or the other length of the building? So this is a lot of stuff I'm explaining. And I guess the thing I'll leave you with there is that this by itself can cause a lot of extra shop and field work. And it can drastically affect the erectability of exterior pieces, especially if it's shop applied. So you want to make sure it's really understood and closely coordinated with both the fabricator and the erector, exactly what you're required to do with slab edge. Then the last quick thing here is using whether or not you're going to use bar stock. The fabricator is going to look for bar stock and use that. Now, oftentimes you'll see this for strip embeds or even just standard shear tabs, like a standard width 4-inch or 3.5 or 4.5-inch wide bar stock. And this used to be a big deal back in the day, like where fabricators would ask detailers to explicitly call that out and check the available bar widths and based on the machines that they had in the shop, if they were going to shear just standard bar lengths or if they were going to burn them on their plate tables. Now, again, it's still important to ask the fabricator this and whether they need us to designate that. Typically, by default on jobs, I like to designate everything as plate. So I set up the models to designate everything as plate, and then I ask the fabricator for them, based on the bill of materials that they get, that they can decide themselves whether or not to use flat bar or to use plate and burn that and feed it exactly where they want to on which machine in the shop. So that's something always worth asking the fabricator. Sequencing and submittals is the next big thing on the project that you really want to get clarified with the fabricator and the erector. And so what we're talking about here is that you want to understand exactly the direction that the erector is going to build the building. And you want to know what corner they're going to start with and which steel they need detailed and fabricated and shipped to the job site first. And so on really large jobs, you actually may break the job down into separate sequences and even submit your shop drawings out for approval and fabrication based on those sequences. And so here on this particular job, the fabricator told me that, hey, there's a west structural and an east structural, and then anchor rods and embeds for the whole job are in their own sequence. Now, one thing that's really important to look at here is that if you need to understand the order in which something will be erected, like the actual timeline order. So if you look at, even though the fabricator told me, hey, grid line 10 is the separation point, I put all of the steel that's along grid line 10 in the west structural because the columns and beams there need to be erected before anything in the east structural sequence is erected. So all those beams need something to frame to. So whenever you're doing match lines on your sequence and phases, make sure you truly understand exactly which one's being erected before the other, because it can have an impact on making sure the right steel is already at the job site at the right time. Now, the other key things here to really make sure you understand is that some fabricators have different standards about wanting assembly marks or detail marks separated by sequence. Sometimes they'll want the shipping marks to be separated and have the actual phase or the sequence number in the marking system. So pieces that are in the west structural cannot have the same mark as pieces in the east structural. Now, they may separate the assembly marks, but then on the submaterial part marks, they actually may want those to cross the entire job. And they just want you to give them a single part drawing that tells you a quantity per phase as each submittal goes out. So these are all things that you'll want to see if you can find in their detailing standard or ask them what their preferences are during the job kickoff. All right, so one of the biggest ones is drawings and your piece marking strategy. So you'll want to look at the detailing standards or ask the fabricator, hey, what are the available sheet sizes that I'm supposed to draw my assembly drawings and make my erection drawings to? So a lot of fabricators, if they do one piece or one piece mark per drawing versus having multi-drawings where you have multiple assembly marks like on a 24 by 36, most fabricators will say start with 11 by 17 because that's easy to print on smaller printers. And then if you can't fit that on 11 by 17, then go to 18 by 24 and then a 24 by 36 for a large complicated assembly. And then if you can't fit something on a 24 by 36, then you start to actually scale the views down. Instead of 1 inch equals a foot, you may use 3/4 inch equals a foot or 1/2 inch equals a foot to fit more things on the sheet size or the paper. Now at ARE11, what we prefer to do is that we prefer not to do multi-drawings. So essentially we only have one shipping mark or one piece mark per assembly drawing. So we don't do the multi-drawings where there's like 4 or 5 beams or 2 or 3 columns per 24 by 36 sheet. We do this because actually the shop has to fabricate based off of each piece mark. And so we can actually use smaller, cheaper printing paper for those. And it's also easier for us as a detailer to manage piece marks and changes if we're managing one drawing per piece mark versus trying to make sure that we have filled up a sheet with lots of assemblies. Now, part drawings, there are 2 different styles of this. I see some fabricators want actually 24 by 36 gather sheets where they take lots of different submaterial parts and put them all on one sheet. Here at ARE11, we try not to do that unless it's an explicit fabricator standard. It is possible, but what we prefer to do is keep each separate part mark on its own 8.5 by 11 drawing or 11 by 17 if it's a little bit larger and more complicated. And then what we'll do is we'll say the quantities of that part on which assembly marks or even in which phase or sequence if that's required. On erection drawings, this is commonly going to be 24 by 36. Erection drawings will often be prefixed with E or AB for anchor bolt plan, and then EM oftentimes for embed plans. And again, these will be 24 by 36 sheets. This will be your erection plans, elevations, and then your sections and details. And then you're going to want to ask the fabricator about revision labeling. Oftentimes you'll see fabricators request that anything that is going out for approval is going to have a alpha character such as Rev A, Rev B, Rev C, etc. And then once it goes to for fabrication for the first time or issued for construction or for field use for erection drawings, then the revision switches to starting at 0 and then 1, 2, 3 progression after that. Then what we want to make sure we ask is what is the title block and bill of material requirements? The out-of-the-box softwares, we use SDS2 and Tekla, and so it's handy if we can use as much out-of-the-box as possible because there's lots of different settings and switches that we can use that tie information in the model. So we need to ask right away that, hey, can we use one of these styles out of the box? And then just make sure we add their logo and their information and their project information. And if not, Then we'll actually ask the fabricator if they already have the title blocks and bill of materials built in the software, especially on the Tekla side. And if not, from there, then we just need to kind of build in some time and hours into basically building that up for the fabricator on the first project that we do. Then the last really important thing here on drawings is that I almost always ask for sample drawings at the beginning of the job. If the fabricator doesn't have this shown in their detailing standards, I always ask, hey, can you just send me some beams, columns, and assemblies that are similar to this type of job, and send that as examples for us to start with. That gives us a good idea of what kind of things the fabricator needs, what's going to be automatic from the detailing system versus something that we have to manually do. And I may even go back to the fabricator and ask them, hey, would you mind working with us on this, because this is going to add a lot of time and potentially affect the schedule. So this is something good to really try to line up at the beginning of the job. If they don't have any standards and they don't have any examples to send you, then I always send our standard set of drawings. Shows our default title blocks, the example styles of how we dimension things and label things, and then I ask the fabricator if they'll just go ahead and approve and work with those. All right, piece marking is also really a big deal. And making sure you understand this, and whether piece marking is going to be separated by sequences or phases, what are the prefixes, what are the labels. I have seen time in and time again, that detailers who are using like the 3D modeling detailing softwares, they just start putting things in the model and they'll forget to change this or forget to get this figured out, and then they have to come back afterwards, even after they're connected, and start changing and modifying this. And it gets really bad if you've already actually started making your shop drawings, because if you have to go back and affect your numbering and piece marking, you're just going to have to deal with lots of marks changing on you and drawings being revised, and you don't want to do that. So it's super important to understand exactly how the piece marking is going to work on a job at the early stages, understand the prefixing system, whether or not the sequence or the phase number needs to actually be in the mark, and then coordinate with your your Tekla or SDS2 administrator to figure out exactly how they need to set up the job, so that way you get the right piece marking. All right, so the next thing to really map out is your transmittals and your submittal delivery. So really understanding from the fabricator's detailing standards or just submitting an example of a submittal package to them, coming up with a standard naming convention of your folder structure and what the name of the submittals, or even giving them like a transmittal number, just so that way it's super clear to the fabricator for each submittal, what it's for, when it was submitted, and what its current status is. And then you want to map out how will submittals be delivered. 99% of the jobs today, you're delivering jobs through electronic transfer, not printing out sets of drawings and then sending them out via a courier service. So is it on an FTP site? Does the fabricator host that site and you put that information there? Or do you have your own file share and then send that across? And that's what we need to get lined up right away at the early stages of the project. And again, Transmittals should clearly designate all of the drawings that are included in it, or if there's any CNC files or reports that are also included, that should be clearly designated and marked on the transmittal, and then what the purpose of that specific transmittal or submittal is for. Now, again, if the job is a little bit bigger and you're submitting by sequence or phase, then you should also make sure that you include that there. So that way the fabricator knows that, hey, this is exactly the right order and the package that I was expecting, and they can see which date that was submitted to them. So then expanding in beyond drawings to CNC and different bill of material and BIM exports, the first thing that you'll want to look at is the standard that we'll pretty much include for a customer is the DSTV standard. And this is pretty common. Both Tekla and SDS2 export this, and most fabricators will accept that and can process that. Now, with SDS2, there's actually specific fabricator settings that you can actually purchase and that work for specific machines. And so we just need to coordinate with the fabricator exactly which file format and which settings that they want. And I always ask the fabricator, if I don't see it clearly in the detailing standards, I ask for a very special and specific meeting where I will do a screen share online with the production control department and the fabricator to show them the options that we have in the 3D modeling software, and so they can see exactly how we want to set things up to give them the best export of files. Now, you'll see that I have it marked in red here. We don't check the individual files. So as a detailer, we're not experienced in actually opening up the individual CNC files and inspecting them and checking them. What I do tell our detailers to do is go through the setups with the fabricator and make sure we conform to those standards. But then from there, we're expecting the fabricator and the production control to review those individual files. Now, as some machines are getting more sophisticated and some of the file formats that are being required, the fabricators are asking for additional types of files. Again, I like to closely coordinate that with the fabricator at the project kickoff so I know exactly what they're looking for. Now, sometimes if there are too many different file formats and different standards and exports that we need to do, I'll actually try to work with the fabricator and say, can we deliver the STS2 or the Tekla model to you and then allow you to extract the exact files and things that you need specific to your processes and to your shop? Now, I'll do this because I want to try to prevent driving up cost and the hours in the detailing side, as well as prevent us from becoming a bottleneck in delivering the information and things that they need, especially at submittal time. And then also from a quality control perspective. The fabricator and production control department oftentimes knows much better, like exactly how they're going to route specific things in the shop based on the drawings and the different types of fabrication. And they'll know exactly where they need the files that they need and for different pieces or assemblies. Now, I often go through the same exact process on the bill of material and the reports. Especially digital bill of material exports like KISS files or FabTrol reports or other XML files that go to the material information and production control softwares at a fabricator. So if this is not in the detailing standards, I almost always ask this in a project kickoff. Hey, what management software are you using? What files and requirements do you need? At which submittals do you need different file types? And, for instance, on FabTrol, there are a few different report types versus a KISS file. And so we just want to make sure that we clearly understand that and when and which information we're supposed to submit throughout the project. Then last item on the list is going through the BIM execution plan. What are the file formats that need to be exported for BIM coordination to the contractor? What is the fabricator required to do? What's the naming convention? Where are those files supposed to be placed? At what frequency? What origin points and rotations. Again, those are all things that we want to understand from the BIM execution plan, or if there is no BIM execution plan, is that in the scope and is that clearly defined, and when do we need to actually do those exports? Now that you've thoroughly reviewed the scope, the design, written all your RFIs, and gotten the fabricator and erector standards clarified, you need to go back and check your schedule. You should at this point have a pretty good feel for the job. You'll know the resources that you've been assigned and the estimated hours, and you want to verify with all the new knowledge that you have on the job whether you can still complete it or if you need to make any changes. Now, oftentimes I'll see a lot of lead detailers when they're checking their schedule, they'll actually take the project start date and then they check things and move forward. Now, the only challenge with that is that in the steel detailing world, usually the dates are already pre-driven and set in the contract. So the fabricator is kind of telling you, and you've agreed that you're going to go out for approval and get the shop drawings and the erection drawings out for this package on this date. And those are not dates that are just locked with the fabricator. The fabricator also commits that to the contractor, and then who also coordinates and commits that to the owner and the design team. So since steel shop drawings need to be actually reviewed and approved by the engineer of record and also oftentimes the contractor and the architect, there's a lot of people who are expecting things to happen on certain dates and certain windows of time. If we miss those actually might get moved to later dates and later times, which can in fact affect your contractual obligations with not just the fabricator, but also all the way upstream to the owner. So it's a really big deal for a detailer, and I almost always train to pull backwards. So do a pull plan, right? So don't just start at your start date and move forward. You know the end date, and you need to check yourself going backwards. So when I'm going backwards from my IFA submittal date here, I'm actually going to start mapping out what are all the different things that I need to do to get that IFA submittal done. Now, in the world of 3D modeling detailing, these steps and these processes are a little bit different than AutoCAD and hand drafting. So back in the day, you used to just count how many pieces there are, guess how many different marks there might be, and you looked at the production rate of how long it took to do a beam drawing and a column drawing, right? So it was very linear, like of just how long certain tasks took to get out for approval. Here in the 3D modeling world, there's modeling, then there's connecting, there's checking potentially in the model before you make drawings. There's making the drawings, cleaning them up, and then checking the presentation, and then processing the package for submittal. So with that all being said, what I almost always see sort of new lead detailers get in a snag with is that they spend a lot of their energy on the front loading of this, and too much time is calculated and used up in the modeling phase, and then they get in a really bad crunch at the drawing, production, and cleanup phase. So when you change your thought process and actually move backwards, knowing how the job is, knowing what the fabricator expects on their drawings, and you think about that ahead of time before you start putting any resources at the front on the modeling, you actually pull backwards and you can check and see whether or not you're going to be in a snag. And you can start to map out, based on production rates, what each of these subtasks should take. When you pull backwards, if you find that you're actually ending up before your actual start date, then you know you're in trouble. Because you can't compress things here all the time. You may have to compress things over here, or you may have to get another detailing resource applied to the project and go back and talk with the fabricator. The point I'm trying to make here that's really important is, again, I see a lot of detailers that get 2 weeks in on the job and halfway through this process, or even all the way to 3/4 and 1 or 2 days before the submittal, and they're in a slam and they can't make it, and they didn't see that it was going to happen to them. When you map backwards and you give yourself the proper amount of time at the beginning here to figure out what you need at these end steps and move backwards, you really are trying to identify problems early. And if you just physically can't make it even after tweaking things, then you go back and you talk with the fabricator way back here at the early project start versus way up here a day before you actually do your submittal. Now, once you do go out for approval, this is the next part of steel detailing management and lead detailing schedule management. If the job has multiple submittals, like in this case, I had one total structural submittal and then one submittal for anchor bolts and embeds. Now, what I typically see on a submittal is that when you go out for approval, the back from approvals are usually contractually required to come back within 2 weeks or 10 business days. And sometimes that gets compressed to 5 days, depending on the job. So when you look at that and you actually start mapping out, when are you going to ramp up resources versus ramp them down, you see that, okay, hey, this detailing package is done. When's the next submittal that's required? The next IFA, the structural. When do I expect the back from approval to come back? Is that going to take away resources that are working on the next submittals or the next phases? And when do they overlap on top of each other? So that's something important to understand. The other thing too is that things don't always sequentially work out on the job. Sometimes the fabricator wants to get anchor bolts and embeds at the same time they want an advance bill. Those aren't necessarily the same tasks in the modeling environment. The anchor bolts really only require the columns to be modeled and putting in the base connections, whereas an advance bill requires columns and all the framing. And you may not be ready to work on the framing if you're working on the anchor bolts. So if you see that on your schedule that both are required and you can't do them in sequential order with the same resources, again, you need to identify that, go back and talk with the general manager and the lead and the fabricator and see if you can get some room to adjust to that or pull resources from other projects. Now, when you do things like that, again, you just need to make sure that the general manager that's mapping out all of the jobs on the projects across your organization understands those changes, and if it creates new pockets of holes of hours in other areas that he wasn't expecting before. So this is all a big part of the scheduling aspect and the hours verification in the lead detailing process. So let's go ahead and do a recap of the things that we need to start up a project. First, we need the design drawings. Most definitely the structural drawings, because that encompasses the scope of what we're typically detailing. And then oftentimes we need the architectural drawings to verify dimensions and additional information that coordinates with the structural. Or if you're doing a miscellaneous steel detailing project such as stairs or other miscellaneous iron and steel, then the architectural drawings will oftentimes supply some of that information. Then we need the specifications if they're available. Sometimes the fabricators will have these and sometimes they won't on the project. And if they aren't there, then basically you're just going to go based off the design drawings for executing the project. Then there's the scope sheet. This is really important to make sure you try to get. Get a clear definition of exactly what's in the fabricator scope and any exclusions that are there, and to make sure that matches what the detailing estimate and scope also shows. Get a hold of the BIM execution plan if possible, if there is one required on the project. Looking for the specific types of exports that you need, the frequency, and any of the coordination origin points or rotations in the model, and naming convention on the files. Then we need the fabricator detailing standards, making sure you understand the marking strategy, how drawings and title blocks are going to look, as well as standard types of connections, erectability standards, as well as other RFIs that are typically asked by the fabricator or the erector on projects. And lastly, most importantly, that we just covered was the schedule with key milestones, making sure that you clearly know when the dates are, and after you fully understand the scope of the project, the fabricator's needs, and the potential issues that you're going to have to face on the design, can you actually make the different dates in those submittals and those milestones, and evaluate whether or not you need to pull additional resources in, or if you have to go back to the fabricator and adjust the schedule, then you want to do that early on in the project, so that way everybody has time to adjust.